Hello everyone, I'm Sophie from University of Illinois at Urbana-Champaign. Sorry for a little bit delay. I'm really happy to present our work. But first of all, during my presentation, everyone please feel free to stand up and stretch your arms and legs because it has been a really long day and finally we made it to the last speaker. And also it's because we're going to talk about something really exciting. That is using submission log data to investigate novice programmers' employment of debugging strategies. So the student behavior we're interested in here is debugging. It is a process where students find out exactly where the error is and how to fix it. However, debugging is usually a comprehensive and challenging task for novice programmers. And for many cases, instructors are unavailable and left students to figure out this question, why does my code not work by themselves? So to better help students to figure out this question, a lot of studies have been done to identify debugging strategies. Qualitative analysis has used think-aloud interviews and other methods to extract students' or experts' knowledge about programming. But usually it is time-consuming and can only be applied to a small scale of students. On the other side, log data analysis has been used to discover latent learning pathways in students' programming process. But currently, limited work has been done to describe their debugging strategies. So to fill up this research gap, in this study, we are trying to answer two research questions. The first is, what debugging strategy do students employ when they are fixing test errors? Second, what are the strategies that differentiate efficient and inefficient debugging? So here, actually, we are showing an illustration of our study design. And the main idea of our study is to connect the debugging strategies from the literature with log data we have. To have this connection making sense, we need to define an analysis unit where we can capture students' debugging behavior. That is the debugging episodes here. And we are more interested in how the different features about debugging strategies can be correlated with efficiency in debugging. That is what we are trying to answer in research question 2. So the data set we collected came from an introductory computer science course where students would submit almost daily programming homework questions with Java. And they would submit their submissions to an online auto-grading system with a limited number of submissions before midnight. And in return, they could get syntax, check style, or test errors. Here is one example showing one student trying to solve one homework questions. And we can see that they submitted 13 times to reach to the final correct solution. So we collected this data set in 2 semesters. For fall semester, there were over 700 students. For spring semester, there were over 400 students. And for both semesters, we had over 70 homework questions. On the average, there were 7 submissions per question. After we get this rich data set, what we were really interested in is the moment where students, they show their debugging behaviors. So our next step is to extract debugging episodes as a sequence of multiple submissions in a row where students receive the same test error. So here is one example. Within the 13 submissions, there were 5 submissions where students received the same assertion error, which is a typical test error in Java. So we would extract these 5 submissions together as one debugging episode. Further, we would define the efficiency of debugging episode as whether students are repeating the same code through the whole episode. For example, here in submission 6, students submitted the exactly same code as in submission 3. When this moment happens, we would assume that probably in submissions 3 and 4, students struggled to fix this assertion error, but they failed because they went back to the same code as before. So we would label submission 3 and 4 together as one inefficient debugging episode. For the right 3 submissions, the students fix this test error and reach to the correct solution in the end. So we will label these 3 submissions together as one efficient debugging episode. There are also cases where students never repeat the same code when they are solving this problem. So we would label these episodes as efficient. After getting all this efficient and inefficient episodes, we got over thousands of episodes for both semesters, with inefficient one versus efficient one around 1 versus 4. After getting all those episodes and their efficiency, what we were really interested in is the detailed behaviors of students within this episode and what they did differently that helped them to reach to the different efficiency level. So our next step is to identify debugging strategy features. We have 15 debugging strategies summarized from the literature as shown in this big table. We also identify related behaviors according to each strategies, as described in the interview or the qualitative descriptions of this strategy. However, there are some strategies that are happening outside of the code where we could get, such as thinking. It's kind of blocked here. But when students are thinking about what to do, we couldn't capture those mental process through their submission log data. So there are some strategies we couldn't cover in our analysis for now. Based on these strategies, we extracted 10 debugging behavior features by firstly extracting them through submission level and then aggregated them to episode level. For some debugging behaviors, such as massive deletion, they would happen binarily in submissions. So we would have proportion aggregation to describe how commonly these behaviors are used by students throughout the whole episode. However, for other debugging behaviors, such as deletion, comment, or print, we could also count the number of code lines where students use this behavior. So we would also have the mean aggregation of these features to calculate to what extent the students are using this behavior when they decide to use it. Next step is we're showing the descriptive analysis results of this debugging strategy employment. We could find that the frequent used debugging behaviors are like deletion, minor addition, minor same addition. Rarely used ones are like massive deletion, comments, and prints. After getting a general idea of how these debugging strategies are employed by students, we are more interested in to discover what are the correlations between these debugging strategies and the debugging efficiency. So we built logistic regression models. Here, let's step back a little bit to the data set we have for now. Here it shows we have data set A, B, and C. The C is kind of blocked here, but it's fine. Although we could notice that although B and C are both efficient, but B is happening immediately after A. And also C down here belongs to the different data set, question set as of A. So to control these differences in episodes, we would build logistic regression models firstly on the entire data set, where we will include data set A, B, and C all together. And then the same question data set, where we only included data set A and B. Different question data set, where we only include A and C together. And this table shows the logistic regression results of 3 different data sets across 2 semesters. If we look at all these values horizontally, we could find that for each significant feature, their slope directions remain constant across 3 different models. So we would conclude that the differences in question set and in the occurrences doesn't really affect our work conclusion. So for the sake of time, for the rest of the presentation, we will only consider the results of entire dataset. And we could find that only a few features are non-significant. For those significant features, the efficient debugging episodes would involve usually higher value in minor edit, deletion proportion, print proportion, deletion mean, comment proportion, and the lower value in minor same proportion, print mean, and comment mean. So what does these results tell us? There are two findings we would like to highlight here. The first is about the employment of debugging strategies. We found that some helpful strategies mentioned in the previous studies are rarely used by the novices in our dataset. For example, the comment and print, although they are kind of expected to be helpful, but the students in our dataset didn't really use them. There are possible explanations to this. First is that we use the more like self-contained homework questions in our dataset, which is usually require students to submit smaller and easier solutions compared with the previous studies. Also, the students we have in this dataset had limited prior debugging experiences, and they didn't got much instruction to apply those advanced debugging strategies. Another interesting finding is about the contradictive effects of debugging strategies. So here, for the same debugging behavior, we usually have two different aggregations, proportion and mean. But if we look at the results of these two aggregations, they usually show opposite effects on the efficiency of debugging. For example, if we look at the comments and mean, the comment proportion and print proportion, they are positively correlated with debugging efficiency, which means that if the students are adding more comments or prints in more submissions throughout the whole episode, they are more likely to be efficient in debugging. But if we look at the mean aggregation, their slope is negative, which means that if the students are adding more lengths of comments and prints within one submission, they are more likely to be inefficient in debugging. This finding is actually aligning with some of our previous findings where scholars are arguing that maybe extensive use of strategies may be inefficient. And also it is an important reminder for us that sometimes we need various aggregations of the same behavior in analysis because they may have opposite effects on our target variable. There are still a lot of improvements to be made. The first is, in this study, we could consider more detailed metrics beyond the frequency aggregations. Also, when labeling debugging efficiency, we came into several challenges. One of them is that we kind of struggle to find the suitable metrics to define debugging efficiency. We also considered the duration students use or the number of submissions they use when debugging, but they were kind of conflicting with the debugging behavior itself because sometimes when students are spending more time in debugging, it doesn't necessarily mean that they were less efficient in debugging. So for future work, we would love to consider debugging. I guess it's better.
Tornado warning from the National Weather Service. Stay in the room.
Okay.
Move up from the back, move up a bit, I guess.
Okay. Okay, thank you for this surprising background music. Okay, I will
Any
just...
questions for Sophie since we're stuck here for a while by the look of it?
Yeah. I will just quickly go through my
Oh, sorry.
last slide.
Okay.
Yeah. Yeah. So for our future work, first of all, we would like to consider debugging more as a process instead of a more aggregated perspective. And we are applying sequential analysis methods to the data set and the features we have. And also, we could consider to inform instructions to encourage students to apply helpful debugging strategies during their programming process. Yes, that's all of my presentation. Thank you for listening. And if you have any suggestions or questions, that would be super helpful for us. Thank you.